Okay, now let's talk about includes. Now, includes is a little different from the way that we've been writing the other array methods that we've covered so far. Includes is essentially a method that takes a single argument, and that argument will be any element that we want. And what it does is it checks inside the array to see if the element that we passed it exists in our array. So let's try this out. Well, let's first make our array, which is equal to, let's say 1, 2, 3, 4, 5. If we do myArray.includes 3, we'll see that it's true because 3 does exist in our array. Now, if we were to say try something like 9, then we would get false because 9 is clearly not inside of our array. The second argument we could take in our includes is the index in which we want to start searching. So what do I mean by this? Well, our array is actually indexed from our first element to its last element starting from 0 and counting up by 1. So 1 is our array element at index 0. 2 is our element at index 1. Now I know with this example, maybe it's a little confusing. So let's do another array. Let's use const new array equals these 3 objects. Well, new array at index 0 is our first element, right? Our first object, ID 1. Element at index 2 is our last one because this is 0, this is 1, and this is 2. One thing to keep in mind with using includes and our second argument, let's say in our original example with myArray, we wanted to see if the number 2 exists starting from our third index. This means that it's starting from 4. It's going to check if 4 includes our 2, it doesn't, or our 5 has our 2, which it doesn't. So here we'll see that we will get false. So essentially, if we were to try this, except instead we were to start from our second index, well, we'll find that it's true. Because starting from 2, it'll see that 2 is included starting from this part of the array onwards. But this is essentially how it works with includes when it comes to using what are called primitive types. Now, I'm going to explain what those are, but first I'm going to show you why this is important. If with our new array, let's say, for example, we wanted to find our second object with ID 2. If I do new array dot includes and then I try to find the object with ID 2, well, we'll get false. But why is that? Even though this object looks exactly like the element that does exist inside our array, why would we get false? Well, this is because of the way that JavaScript references objects versus primitive types. Now, what are primitive types? Well, let's actually look at this diagram here. In this diagram, imagine there's a memory bank, and this is internal to JavaScript. Inside this memory bank, JavaScript has a reference to every primitive type, and there are 6 of them. There are strings, strings being anything that we see between quotation marks. So this is a string, Boolean is true or false. Null is the null object. Undefined is also undefined, a unique primitive type. Numbers, so this is any integer, right? So that's any whole number. And also any float, so any decimal number. These are also all primitive types that fall under the category of number. And symbol, which is a bit more complicated, but it's essentially a unique thing. We don't really want to go too deeply into symbol because we're not really going to use it, but these are the 6 primitive types. And these primitive types all exist inside of JavaScript's memory bank. Now, when we set a constant or a variable equal to a primitive type, like say the number 3, what JavaScript is doing is it's creating this new variable that we want called a, and it's pointing its value to the number 3 in its memory. So it's actually pointing to 3 in memory. Now, when we set variable b to 3, it does the same thing. It creates this new variable called b, and then it also points to the same 3. Points to 3 in memory. If we set variable c to b, it's actually not pointing to our value of b. Instead, it points to b, which then points to our value in memory of 3. If we were to see this in action, let's say we did var b equals 3 and var c equals b. If we look at c, we'll see that the number is pointing to 3. If we changed b to 5, b is now pointing to the value in memory of 5, right? It's not really setting a value. We're saying that our value of b wants to point to the 5 that's in JavaScript's memory. But c is still pointing to 3. So c is not always going to equal whatever b becomes. C will only point to the value that b pointed to when we set it. Why was it that this didn't work? Well, inside of JavaScript, anything that's not a primitive type, so not any of these 6 types, is called an object. And an object is unique. Whenever an object gets instantiated, it gets its own unique reference in memory. Now, before we explore this, what is an object? Well, everything else in JavaScript that is not one of these 6 primitive types, as we mentioned, is an object, right? So arrays are also objects. And you can essentially just see objects as collections of things that have properties that have values. So my array, right, the arrays that we've created, they all have properties, right, because they have these methods on them. And methods are pretty much just properties that point to functions. That's why we're able to use them like functions. But we call them with the dot notation like it's a property on the object, right? And we're used to seeing objects as these curly braces with key value pairs inside them. Well, you can pretty much see that as everything else in JavaScript that is not one of those 6 primitive types that we're talking about. Now, whenever you see an object get instantiated for the first time, or for any time for that matter, what you're seeing is JavaScript store that object as a brand new reference in memory. So what do I mean by this? Well, let's say we made a new const object 1, which equals to this object with the ID of 1. This object gets a new reference in memory. Even if we were to make a new object 2, right? Let's say we were to point it to a different object, but it looked the exact same. This is actually going to be different. If we do object 1 equals object 2, it's going to give us false. Because what JavaScript is comparing, if the reference in memory is the same. It's not comparing whether or not this value of this object is equal to each other. It's comparing if they're both pointing to the same place in memory. This only works if we were to do something like we did earlier when we pointed our value of c to b. But instead, if we were to say point our const obj3, right? So this new const, we want to point to object 2. Well, now we'll see that obj3 is pointing to this object. Now we can see that because both object 3 and object 2 are pointing to the same object in memory, if we do a comparison, we'll see that it's actually true because the reference in memory is the same. Now, the interesting thing about objects is that if we change the properties on them, if we add them or modify them, they'll always point to the same object reference in memory. So if I were to do object2.id equals 17, well, now object 2 is ID 17, but object 3, you'll see, still points to the same object in memory. So that would be how we would get our includes to work, is we would actually do const o1, right, equals a new object with ID of 1. Const o2 is equal to another object with ID of 2. Const o3 is equal to an object with ID of 3. And now we'll say const newest array is equal to o1, o2, and o3. So now if we were to display it, we'll see that inside our array is those 3 objects that we just made. And now if we do newest array dot includes, and we were to point to, let's say, o1, we'll find that it's true because what we're referencing is that pointer in memory. So even though our array is this array, the elements inside are not new objects, but they're all pointing to the same elements in memory, which is why when we do the includes, the evaluation is true, because that's essentially what includes is doing under the hood. It's checking if the reference that we're passing in, right, is equal to any of the elements inside by their memory reference. So this is a bit of a longer lesson because we have to understand this very fundamental thing about objects and how JavaScript stores things in memory, but also how includes works when comparing and trying to find if an element exists in the array. We'll definitely explore these concepts a lot more as we code, and they'll definitely make more sense why the code we write is structured the way it is based on these rules.